The philosopher Toby Ord believes that our current historical moment, if we survive it, will be defined by our vulnerability to annihilation, an era he calls the Precipice, in which humanity lives in the shadow of true existential uncertainty. Of countless generations of humanity, only in the last century, roughly one human lifespan, have we acquired the means to destroy ourselves. This awareness permeates our culture, and many have the sense that the end is nigh, that humanity has no future, and perhaps doesn't deserve one. Our news feeds, music, film, and literature reflect this vague atmosphere of impending apocalypse. Runaway climate change, mass extinction, nuclear war, unaligned artificial intelligence. And yet, while the risks to our continued existence are real and in some cases growing, the truth is that these risks are far from insurmountable, and even now, the long-term survival of humanity and our descendants remains a real possibility. The enormity of our potential can be viewed through two lenses: our physical potential to explore a vast and mysterious universe, and our mental potential to explore an equally vast and unfathomably valuable dimension of consciousness. Today, we will explore both of these lenses, physical and mental, for the sake of shedding light on the surprising cosmic significance of our unique historical moment. Part 1. Cosmic Reach. Could we really settle other planets? Could we ever traverse the vast gulfs between stars? Could our descendants truly come to inhabit deep time? We will consider the possibility that we do survive the precipice with our potential intact, and what we and our descendants could eventually author on the cosmic stage. For the moment, taking humanity out of the equation, scientists predict Earth is likely to be habitable for another 500 million to a billion years. In this time, among other changes, the Moon's gravitational pull will gradually stretch the length of an Earth day, and continental drift will reshape the surface of the planet. The occurrence of major natural cataclysms will accumulate in probability, such as the eruption of supervolcanoes and Earth-asteroid collisions. These events, while devastating, are in fact quite unlikely to put a permanent end to Earth's habitability for complex life. It is only after hundreds of millions of years that Earth life faces certain existential risk from natural origins. The threat will eventually come from our star, the Sun. At 4.6 billion years old, the Sun is about halfway through its lifespan. Throughout its life, the Sun has grown steadily brighter and will continue to do so as it ages. Eventually, this brightening effect will begin to pose serious challenges to any then existing life on Earth. Unchecked, the increasing glare of the Sun will boil off Earth's oceans, and with them all prospects for complex life will also quickly evaporate. Our descendants, however, may be more than capable of averting this disaster. If they can find a way to block 1/10 of the Sun's incoming light, perhaps even converting it into usable energy, we may be able to extend Earth's habitability for another billion years or more. For an advanced civilization, with the abundant resources of our solar system, such a feat is far from impossible, and if successful, will effectively save all then existing life on Earth. Long before this time, our descendants may carry out other ambitious interventions, such as scrubbing our atmosphere of the pollutants of industrial civilization, re-engineering collapsed ecosystems, and resurrecting the species we drove prematurely to extinction. A future civilization may also capture a significant amount of the total energy given out by the Sun. Massive solar collectors placed in orbit around our star could store and distribute its energy wherever we need it. Interventions by our descendants may significantly prolong Earth's habitability for life. And yet, eventually, our continued survival will require us to move on from this planet, and indeed anywhere else we might have settled in the solar system. The threat, once again, will come from the Sun. Between 4 and 6 billion years from now, our star will enter the final stages of its life, in which it will dramatically grow in size, eventually ballooning outwards beyond Earth's current orbit, finally exhausting its remaining energy and dying. Long before this time, our best hope will reside in our nearest star system, Alpha Centauri, located approximately 4 light-years from Earth. Alpha Centauri is a triple star system, 3 orbiting stars, the nearest of which is Proxima Centauri. There is now evidence that this star is orbited by a roughly Earth-sized rocky planet located in its habitable zone. This planet is known as Proxima b. By this stage, we may not strictly need such a planet to establish a foothold in this system. Perhaps by then our descendants will occupy habitats that transcend the need for a planet. And yet, the existence of Proxima b is a stroke of fortune that may be of great value to our descendants. But could we ever reach this distant world? The possibility of true interstellar travel is often met with skepticism. But it should be pointed out that much of this skepticism is directed to what is possible in the relative short term, the next century or so. We've simply not yet developed the technology to transport ourselves between stars. And yet, while this may prove to be very difficult and time-consuming, there are in fact no known limits that make interstellar travel impossible. And should we survive this vulnerable moment in our history, we will have millions of years to plan such a voyage, and, if necessary, thousands of attempts. If our descendants do arrive at Proxima Centauri, a settlement built from local resources could eventually establish a thriving new centre of civilization. And we could also take the rest of life along with us, transporting the seeds and cells required to birth new biospheres on new worlds. Future generations may have the means and desire to undertake this voyage millions of years before the Sun's death forces our evacuation from the solar system. Establishing an interstellar civilization would dramatically reduce our vulnerability to natural risks. And yet, as we shall see, this is just the beginning of what conscious, intelligent life might eventually author on the cosmic stage. There are around 15 million stars in our local stellar neighbourhood. Most of these, we now know, have orbiting planets and moons. These stars are spread apart from each other at a roughly even distance of 6 light-years, slightly further than our distance to Alpha Centauri. This means that should we successfully reach this neighbouring star system, the entire galaxy would effectively open up for us, hundreds of billions of stars and trillions of worlds. It has been calculated that if we travelled at just 1% of the speed of light, and upon arrival took a leisurely 1,000 years to establish each new settlement, we could colonise the entire Milky Way galaxy in just 100 million years, long before Earth is predicted to be uninhabitable, and a mere blink of the eye in cosmological time. To put this into perspective, consider that this is less than a quarter of the amount of time that the humble horseshoe crab, one of the oldest existing species of animal, has inhabited Earth's ocean floors. 100 million years from now, the Sun will still be middle-aged. Earth may still be habitable, and the horseshoe crab may still be observing its yearly migrations. Our galaxy, the Milky Way, is home to many species of stars, some of which will burn for trillions of years, thousands of times longer than the Sun. There will also be millions of future generations of such stars, offering a near inexhaustible abundance of energy. If we can secure our existence amid such cosmic scales of time, our current 21st century civilization will appear astoundingly close to the very beginning of history and the very beginning of knowledge. A barely sprouted seed, tiny and vulnerable, yet carrying the potential of sowing a near limitless forest of life. Part 2. Life Beyond Earth. What discoveries might await us beyond Earth? The most significant discovery we could make is other life. The discovery of life in our galaxy would carry profound implications. Should we find just one instance, it would mean that life has almost certainly evolved in billions of other places in the universe. We now know that the universe has existed for over 14 billion years, and has long been rich with the essential elements for life. As far as we know, there has been plenty of time for other intelligent life to evolve, perhaps greatly beyond our own level of advancement, and even going some significant way towards realizing its cosmic potential. So where is this life? It is often said that the universe seems lifeless, that if other civilizations really existed out there, the night sky would be littered with signals of their presence. The famous Fermi paradox emphasizes how curiously alone we seem to be. One possibility is that intelligent life is out there, and that we are simply mistaken in thinking that its presence would be obvious. After all, even we, with all of our emanating electromagnetic signals, could easily be overlooked by comparable telescopes to our own. The truth is, we have barely begun to look for other life, and as the SETI-based astronomer Jill Tarter points out, we have scarcely examined 1,000 star systems, the equivalent to a single glass of water in all of the oceans of the world. It is therefore far too soon to declare ourselves alone in the universe, our galaxy, or even our local stellar neighbourhood. One possibility is that advanced life will have evolved beyond the kinds of physical presence we could detect. The physicist Michio Kaku has spent some time considering this possibility. Kaku believes it will one day be possible to encode our minds into pure information, and that this information could then be composed within light. Using a method called laser porting, Kaku proposes that we may one day transmit our minds via laser across the vast gulfs of space. Once received at their destination, a mind composed within this light could be reinstantiated within a remote avatar, a physical form of our own design. Of course, the receiving technology would need to be sent in advance, and yet such a method would avoid all of the complications and accompanying risks of launching biological life into space. Kaku argues that light may well be the fastest and safest way for our minds to traverse space, and that this technology may represent a convergence point for intelligent life. Kaku believes this is why the universe seems so curiously silent of life. In actuality, there may be an invisible superhighway of intelligent life right above our heads that we have no current way of detecting. If Kaku is correct, perhaps humanity shares in this destiny to eventually evolve into beings of light. But should we fear an encounter with other intelligent life? While even responding to a distant potential signal should be approached with extreme caution, later we will explore some of the compelling reasons to consider that other advanced intelligent life would share a surprising number of our highest values. including intelligence, benevolence, and compassion. But for now, let's move further ahead and consider the potential of our descendants in deep time. Part 3. Deep Time. There are around 50 other galaxies in the vicinity of the Milky Way. This cluster of galaxies is known as the local group. Closest to us and the largest of these galaxies is Andromeda, a beautiful spiral galaxy made up of hundreds of billions of stars. Andromeda is a galaxy similar in form to our own, but around twice as large. Might our descendants one day voyage to this neighbouring galaxy? While reaching other stars may entail at best a significant challenge, at millions of times the distance, skepticism about the possibility of intergalactic travel is well justified. But before we rule out the possibility of intergalactic travel, we should spare a thought to all of the modern realities once considered utterly impossible. From the splitting of the atom to human flight, from our very early vantage point, it is far too soon to rule out that a civilization that has mastered its entire galaxy could eventually reach another. So, might we one day travel to Andromeda? In one respect, we may not need to. In fact, if we wait long enough, Andromeda will come to us. Gravity is slowly pulling our galaxy and Andromeda together, and in around 4 billion years, the two galaxies will collide. This may sound like a cosmic cataclysm, and yet because of the great distances between stars, this galactic collision is unlikely to cause much disruption at all to individual stars. Eventually, the two galaxies will merge together completely, creating a new, possibly elliptical galaxy, roughly 3 times the size of the Milky Way. Eventually, over hundreds of billions of years, all 50 or so galaxies of the local group will be pulled together by gravity, resulting in the creation of a single, massive galaxy. As this occurs, similar enormous galaxies will be forming throughout the observable universe, bringing the dawn of a new cosmic era of massive galaxies. The theory of cosmic acceleration suggests that these massive galaxies will eventually be pulled so far apart from each other that eventually no possible contact will exist between them. Any inhabitants of these galaxies would witness as the distant night sky grew ever darker, until even the light of distant galaxies disappears forever. What follows would be a time of relative isolation, in which the inhabitants of individual galaxies effectively strike out on their own, falling eternally further apart. We should keep in mind, however, that this specific chain of events depends on the relatively new and tentative theory of cosmic acceleration. It is still far from certain that cosmic inflation will accelerate indefinitely, and some cosmologists argue that the universe must ultimately cease expanding, and in all likelihood will eventually begin collapsing back in on itself. If so, enormous galaxies, long isolated, will begin moving towards one another, and vast galactic communities, long estranged, will reunite with each other once more. Might our descendants inhabit this distant coordinate of time? Might we witness the unfolding of these grand cosmic events? If conscious, intelligent life should inhabit such deep time, by then its reach and scale might conceivably grow to play an active role in the long-term destiny of the universe itself. As theoretical physicist Freeman Dyson observes, quote, "It is conceivable that life may have a larger role to play than we have yet imagined. Life may succeed against all of the odds in moulding the universe to its own purposes, and the design of the inanimate universe may not be as detached from the potentialities of life and intelligence as scientists of the 20th century have tended to suppose." End quote. In what ways might life eventually reshape the universe? Is it possible, as the physicist David Deutsch has considered, that, quote, "at the end of time, life will have spread throughout space. It will have gained control of all matter and all forces, and it will have acquired all knowledge there is to know." End quote. Through the evolution of conscious life, might the universe itself gradually become conscious? Such a surprisingly life-defined future might cause us to reflect, as Dyson did, on the basic character of the universe itself, that life and mind might have been somehow woven into the fabric of the universe from the beginning. While a controversial subject, the idea that the universe is in some way driven to realize its total mental potential is a possibility that several scientists and philosophers have taken very seriously. One of them is the physicist Paul Davies. Quote, "Many scientists have speculated that as the timeline stretches towards infinity, so an emerging superintelligence will become more and more godlike, so that in the final stage, the supermind will merge with the universe, mind and cosmos will be one." End quote. The possibility that life and the evolution of consciousness are somehow necessary features of reality is an area I've explored in several other videos. Suffice to say that I consider this a real possibility that at least we cannot yet rule out. Part 4. More than human. How might humanity transform over millions of generations? The powers to alter our physical and mental capabilities already exist, albeit in embryonic form. Whether we embrace these emerging technologies or fear them, their eventual use may be a near inevitability. Many are resistant to what is termed transhumanism. There is a very real and legitimate fear that in altering human nature, we risk losing something of great value, perhaps without even realizing it has occurred. An extreme example is that humanity might be succeeded by artificial intelligence, superior in many cognitive dimensions, and yet should these beings lack consciousness, a capacity for experience, we would effectively lose the possibility of value itself. Transhumanism, however, does not necessitate relinquishing our consciousness or our humanity. It is highly likely that our descendants will acquire the means to radically upgrade existing human traits: intelligence, concentration, compassion, imagination, and memory. These enhancements, as Toby Ord points out, quote, "could make possible entirely new forms of human culture and cognition, new games, dances, stories, new integrations of thought and emotion, new forms of art. And we will have millions of years, maybe billions or trillions, to go much further, to explore the most distant reaches of what can be known, felt, created, and understood." End quote. It is the potential of our descendants to inhabit levels and regions of consciousness barely glimpsed in the peaks of current human experience. The philosopher David Pearce believes that advanced minds might entirely eliminate experiences of pain and suffering, and re-engineer their mental architecture around information-sensitive gradients of bliss, transcendent of anything we can presently conceive. But what of human nature? Should we transcend our evolutionary idiosyncrasies, or pridefully preserve them in perpetuity? If we recognize consciousness as the domain of all value, we should also recognize that the human mind can glimpse only a tiny fraction of this space. There is an immense ocean of possible conscious experiences, of which present-day humans are only dimly aware. Indeed, the vastness of the potential value in consciousness mirrors the vastness of the universe, a near limitless possibility space that we have scarcely begun to explore. Part 5. The Universal Self. Current thought in the philosophy of identity in some ways mirrors that of ancient mystics, that what we typically think of as the self is in fact a kind of illusion. Instead, the single common factor of all of our experiences is consciousness itself, and it is this quality of consciousness that should be considered the proper carrier of identity. This perspective has been called open individualism. Only an identity based in consciousness provides sufficient consideration of the distant future and the beings that will inhabit it, that in whatever ways we might evolve or seek to alter human nature, whatever physical forms our descendants might assume, biological or silicon, to preserve our true value and potential, we must preserve consciousness. Might such an insight eventually dawn on all sufficiently advanced minds in the universe? We often think of ethics and morality in human evolutionary terms, but is it possible that the development of consciousness eventually converges on ethical precepts that are universal to all sufficiently advanced conscious minds? It seems likely that when directly focused on the evolution and preservation of consciousness, it will always be preferable to cultivate rather than stifle creativity. That cooperation will always be preferable to conflict, compassion will always be preferable to cruelty, and knowledge will always be preferable to ignorance. Could it be that none of these values are characteristically human, but instead relate, as all values necessarily do, to consciousness and its evolution, wherever it might be occurring in the universe? There may be a great diversity of minds in the universe, with very different evolutionary histories, cultures, and cosmologies, and yet the highest values towards which their cultures tend may well be closely aligned. In such a view, there is the hope that war, hatred, and slavery are but strategies of diminishing value to be overcome in time, relics of a history of tribalism that we will not carry with us to the stars. If advanced beings converge on consciousness as their identity, they would see themselves in all conscious beings they encounter, and as real centers of moral and ethical concern. And should we finally meet other intelligent conscious minds in the universe, we might see each other as extensions of ourselves on the same journey with the same goals. The philosopher David Pearce believes that such an ethical convergence may in fact be what impels our descendants to voyage to the stars. For Pearce, our impetus to venture beyond the solar system may well be, in effect, a rescue mission, wherein to fully discharge our ethical duties to other beings in the universe, we must seek them out and do what we can to alleviate their suffering. In his writing, Pearce pays particular attention to the suffering entailed by Darwinian evolution. For Pearce, advanced conscious intelligences may think very carefully before seeding other worlds with life. And should they decide to do so, they might attempt it in ways that are more compassionate than nature herself has implemented on Earth, perhaps even eliminating predation and suffering altogether. If such a biosphere could really be engineered, it would no doubt look very different to that of Earth. We can only guess how future minds might perceive their world, or what they might believe about the nature of reality. Will they view mind's significance as singular and pervasive? Might they view the universe as essentially alive? Today, we stand at the forefront of 10,000 human generations. Now, in our lifetime, their every sacrifice, every stroke of insight, every hard-won achievement hangs in the balance. Emerging technologies could both annihilate us or catalyse an astonishing odyssey to the stars. There could be hundreds of millions of future generations to come, and yet our present historical moment may well be the most significant, when it could all have been over before it barely began. In this time of the precipice, the unfathomable value of our future potential depends on the relatively tiny number of humans now alive today. In this sense, we live in a time of true cosmic significance. We know of very few limits that truly constrain what conscious, intelligent life could eventually author on the cosmic stage, if only we can survive to do so.